Hello everyone, welcome to the class. So today we are going to discuss four major topics. First one is quantum mechanical model of the atom. So basically the quantum mechanical model of atom is a modern model of the atom which is basically based on it is based on quantum theory, which was given by Erwin Schrödinger. So basically ये theory जो है, this theory, quantum theory, describes the electron not as a particle in a fixed orbit जैसा कि बोहर मॉडल में था, but as a wave-like entity with the probabilities of being found in certain region in space, not in orbit like Bohr said, but according to this theory, electrons are behaving as a wave. Electron is a particle. Electron is a particle. This is being said by Bohr. But electron is a wave. It is being said by quantum theory. So basically on the basis of this consideration, electrons are supposed to be found in region around atom, that is what we called orbitals. So basically the concept of orbitals is being introduced by quantum mechanical model, whereas in case of Bohr model, the electrons which are considered as a particle are happen to be found in orbits. So if we look after the basic key features of the quantum mechanical model, the first one was wave particle duality. That was indirectly introduced by de Broglie. Introduced by de Broglie. De Broglie's hypothesis basically. So what he did is he considered the energy associated with the electron is equal to h nu, that was given by Planck's quantum theory. And secondly, he considered Einstein mass energy equivalence, that E is equal to mc square, that mass and energy is interconvertible if the particle is moving with the speed greater than the speed of light. So basically by adjoining these two relations, we get h nu mc square, nu is equal to, as nu is equal to c bar lambda. So c bar lambda is equal to mc square divided by h. One c is going to cancel out, then we get lambda is equal to h over mc. Since we are considering the wave and particle duality, we are trying to establish the relation which is going to hold good for both particle and wave. So basically in case of wave particle, the speed of light is equivalent to the speed of light, but in case of particle, the speed of light, that is 3 into 10 raised to power 8 meter per second, is most of the time cannot be achieved. So basically we rewrite it as lambda is equal to h over mv, where v is the velocity of the particle, or it can be equivalent to the speed of light in case of the particle is moving with the speed of light. So also we know that the linear momentum p is equal to mv, so the relation can also be rewritten as lambda is equal to h over p. Even we know kinetic energy, let's say E is equal to half mv square. E is equal to half of, we divide the relation with m multiplied by m, it becomes m square v square. So if we find the value of mv square, this becomes equivalent to 2me. We're going to put this value over here. You will get lambda is equal to h by root of 2me. So this is the third relation that we need to remember. This was the first input towards the quantum mechanical model that was given by de Broglie hypothesis, that there is the duality in the wave and particle nature in a microscopic world. Second insight was given by Heisenberg. Heisenberg uncertainty principle. Which concludes that we cannot find exact position and exact momentum of a microscopic particle simultaneously. That both the position and momentum of a microscopic particle cannot be concluded or cannot be calculated precisely simultaneously. So basically this principle is going to work against the Bohr model, in which both the position, that is the radius of the orbit in which electron is revolving, and secondly the energy associated with those electrons in a specific orbit, both are given simultaneously or can be calculated simultaneously. So by coming up of this Heisenberg uncertainty principle, those points in the Bohr model got spoiled, and that's why those were the major setbacks to the Bohr model. So basically, according to Heisenberg uncertainty principle, the uncertainty in position and uncertainty in momentum is always greater than equal to h over 2 pi. It's 4 pi. Or you can say, we know that as p is equal to mv, or mass of the microscopic particle will not change. However, for the change in momentum, there will be the change in velocity. Then we can rewritten as delta x m delta v greater than equal to h over 4 pi. This becomes delta x delta v greater than equal to h over 4m pi. So these two relations should be in mind, besides the definition of the Heisenberg uncertainty principle. And besides all this, the Schrödinger wave equation, that is h cap psi is equal to E psi. This is the short form of Schrödinger wave equation. Can also be written as in a three-dimension form. That's not going to complement the upcoming task in the syllabus, so we are skipping that. So basically, the square of this wave function, square of this wave function, psi square, gives the probability. This gives what? This is the probability density of finding an electron in a particular region. How we are going to find the electron in a specific region? What is the probability of finding that electron in the specific region? It's given by psi square. So basically psi square is specifying the orbital. So basically using this equation, we are going to find some specific values. Those values, few of them are of significance, and those values which are going to get as a solution of this equation are combinedly called as quantum numbers. Quantum numbers. Quantum numbers are basically what? These are the solutions of the Schrodinger wave equation. So there are basically four type of quantum numbers. First one is principal quantum number, that is denoted as n. Second one is azimuthal quantum number, denoted as L. Third one is magnetic quantum number, denoted as ML or M. The fourth one is spin quantum number, denoted as small s or ms. These are the four quantum numbers. So first one, that is n, principal quantum number, is going to help in finding the energy of orbit or energy of the shell, energy of the level, energy of the electron which is present in this shell. Whereas L is going to specify the subshell, shape of orbital, where ML or M is going to specify the orientation of subshell. Orientation of subshell means that is, it is specifying the orbitals. And lastly, S, that is going to specify the electron spin. If we talk about principal quantum number N, that also helps in finding orbitals. Maximum orbitals in orbit N is given by n square. Maximum electrons in n orbit is given by 2n square. The value of n starts from 1 and so on. The value of L starts from 0 up to n minus 1. The value of ML starts from, or M starts from minus L through 0 up to plus L. The value of S can be plus half or minus half. So that's all about quantum mechanical model of the atom. If you have any doubts, please comment it down. Thank you.